Sketch the magnetic field pattern due to the currents in a long straight wire, a flat circular coil, a long solenoid. When electric current flows through a long straight wire, it produces magnetic field lines around it. Draw a straight vertical wire. Now draw circular magnetic field lines around the wire. These circles are called concentric circles. Important points on screen. Magnetic field lines are concentric circles. Field strength decreases with distance. Direction is given by right-hand grip rule. Hold the wire with your right hand. Thumb points in the direction of current. Curled fingers show the direction of magnetic field lines. A flat circular coil also produces a magnetic field when current flows through it. Draw a circular loop connected to a battery. Magnetic field lines pass through the center of the coil. Near the wire, field lines are circular. At the center, magnetic field becomes strong and nearly straight. Important points on screen. Field lines are circular near the wire. The field is strongest at center. Coil behaves like a magnet. Use the right-hand rule again. Curl fingers in direction of current. Thumb shows direction of magnetic field through the coil. A solenoid is a long coil of many circular turns of wire. Draw many loops together to form a long solenoid. Magnetic field lines inside the solenoid are straight, parallel, and closely spaced. Important points on screen. Inside field is strong and uniform. Outside field is weak. Solenoid acts like a bar magnet. 4. What happens when current is passed through a flat circular coil? A magnetic field is produced around the coil, which is strongest at its center. 5. Why are magnetic field lines crowded at the center of the coil? The magnetic field is strongest and nearly uniform at the center of the coil. 6. What does a compass placed at the center of a current-carrying coil indicate? The compass needle deflects and aligns itself along the direction of the magnetic field. 7. Why does the compass needle deflect near the coil? Because the magnetic field produced by the current-carrying coil exerts a torque on the needle. 8. Which rule is used to find the direction of magnetic field around a current-carrying conductor? Right-hand grip rule. 9. State the right-hand grip rule. If the thumb of the right hand points in the direction of the current, the curled fingers show the direction of the magnetic field. 10. What happens to the magnetic field if the direction of current in the coil is reversed? The direction of the magnetic field also reverses. 11. How does increasing current affect the magnetic field of the coil? The magnetic field strength increases with an increase in current. 12. How does a current-carrying coil resemble a bar magnet? It produces north and south poles and has a similar magnetic field pattern. 13. Name the device used to detect the magnetic field in this experiment. A compass needle. 14. What happens if the number of turns of the coil is increased? The magnetic field strength increases.